Here we look at a calculation which involves working out a molecular formula. And in order to work out this molecular formula, you initially need to work out an empirical formula. So you've got a question here saying that a compound of boron and chlorine has a relative molecular mass of 163.6 and it contains 13.2% of boron by mass. And from this information, we can calculate the molecular formula. So the first thing you need to do in a question like this is work out the empirical formula from the data given in the question. Remember that we need to make a column for each of the elements in the compound. So I've got a B and a Cl. So remember to make a column for each. We've got the percentage of boron, which is 13.2, and the percentage of chlorine, even though it's not given, we can work it out because the percentage is out of 100. So it's simply 100 minus 13.2 would give us 86.8. We divide them both by the ARs, which you can find obviously in your periodic table, and boron's is 10.8, chlorine's is 35.5. And when we do that, we get an answer here of 1.22, and here we get an answer of 2.44. So remember, once we've got these numbers here, we divide each of these numbers by whichever is the smallest, which is obviously 1.22. And I think we can see where this is going. We get an answer here of 1. And 2.44 over 1.22 is obviously going to be 2. So I've got my empirical formula. And again, don't ever forget to actually write down the empirical formula. It's BCl2. That's my empirical formula. And from this empirical formula and the MR of the compound, which is given here, we can work out the molecular formula. Now, the molecular formula is equal to the MR divided by the MR of the empirical formula times the empirical formula. Now, it looks like a bit of a mouthful, that equation. But actually, when you see the numbers being plugged in, it's not so bad. So the molecular formula then will equal the MR, which is given in the question as 163.6, so I'll put that in, divided by the MR of the empirical formula, so we need to work out the MR of this. When you do that, you should get 81.8. Times that by BCl2. So the molecular formula then is equal to, when you do this calculation here, you get 2 times BCl2. So what it's saying is now we need to multiply each of the atoms here by 2. So my molecular formula then is equal to B2Cl4. And that there is your answer.